Hello, everybody. Thank you for joining our presentations today. Yeah, we've all been working pretty hard on these, so I'm excited that we get to all share them. Sorry, I'm doing a forest fire detection system, and I'll obviously go more into that, but I call it the Forest Alert. So kind of like, who am I? Why did I take this boot camp? I used to work at Electric Playhouse, photo on the right. I did all the fabrication for Electric Playhouse. One of the things I built was the main entryway tunnel over there. And I've always been fascinated with, I've always been a maker. And so I've wanted to like kind of expand my making skills. And then I heard about this boot camp and like got super excited and really wanted to really basically combine the physical and digital worlds together, which is exactly what IoT is. So it's been pretty fun. One of our first project, I built like a dog ball launcher, so your dog can be playing at home and or you can be away from the home and your dog can drop the ball in and it shoots it out. And then we did the automatic plant watering system. So obviously some projects are more useful than others. The project I am working on for the Capstone project is a forest fire detection. So why did I build this thing? Well, clearly forest fires have become a way bigger issue than they used to be in the past. I'm originally from California, so there's a lot of forest fires there. And already this year there's been a forest fire, which is, I guess the forest fire season is kind of year round now there. But I mean, even in 2020, it costs the United States 130 to 150 billion dollars in damages for forest fires. So pretty much any solution to try to alleviate some fires or at least kind of find them early on and prevent them from spreading, I think is like hugely valuable. A lot of houses are currently at risk by being at the border. Yeah, and there's forest fires are only getting bigger and bigger. So good, Brian. Cool. So what did I build? So I built a a remote forest fire detection device. So what it is, it's basically a node-based system where you drop these from a plane or a helicopter. They're fully self-contained, so they have a solar panel to charge themselves. They have all the sensors integrated into them, and each one can then talk to the next one. And so when one finds a fire, it's got a GPS built into it, and it'll ping the other ones saying, hey, I've got a fire, here's all my data. It'll send that to all the other nodes, and then one of those nodes is maybe the central hub node that's either connected to GPS or satellites communication, or if it's close enough, it could be connected to cell reception. Currently, there's a lot of stuff out there that does try to detect forest fires, and I'm not trying to replace any of those things. I think this is an additional kind of tool in the bag for detecting forest fires before they get out of hand. And the kind of key difference with this device would be that it is able to go in way more remote parts of forests or areas that tend to burn, whereas a lot of the current systems they require a lot of infrastructure to set up, like a camera-based system. You got to get a truck out there to pour concrete, or you got to get a team of people out there to kind of install this system. And they work really well, but it requires people actually going out there. So what I'm proposing is basically a system that you can drop a bunch of different nodes that are low cost. This is obviously the prototype. I think I could shrink it down and make it a lot cheaper. And have it go way further into forests. Another kind of key feature is it is constantly tracking temperature, like air quality. It's got a couple other sensors on it, and so you could have it in theory, set up in a way that's also just sending data back for kind of tracking like weather patterns or climate change over time. So it could be used as well to get more data from the forest. And no reception is necessarily required because they can all kind of create their own network using the LoRa that Gabriel was talking about in the last presentation. Sweet. Yeah, so how I started this project is I wanted to first figure out how to detect a fire. So I took five different sensors, and I basically just put them on a breadboard or on like a piece of wood, took it to a campfire and tried to like get an understanding of what each sensor does pick up and how close it actually needs to be to the fire, which ones can maybe be further but still detect fire, basically to just try to narrow down the sensors I needed. So I tested all the sensors on the bottom right there. You're good, Brian? Cool. And what I ended up going with is on the left picture, it's the sensor to the far right I found was the most accurate. It's a laser particulate matter sensor. And basically it can get up to 1 micron of air particles in the air. And I was doing a lot of kind of research on it, but there's basically between 2.5 and 10 particles per million, I guess, is a lot of times where smoke is found. So this thing can pick up smoke, even if the fire is not right next to it or not near it. Generally, the forest fire's smoke rises, but the ash usually ends up falling. So if you place these kind of strategically, maybe on ridge lines or maybe in areas that even if the smoke is rising, the ash is going to eventually fall, and the device will then kind of be looking for that. So it doesn't necessarily need to be right on the fire, but yeah, it can kind of still find fires. I also wanted to check for just temperature and humidity. I noticed when I was doing my testing that obviously the temperature rises pretty quickly when there's a fire nearby, as well as the humidity really starts to decrease because the fire is burning up a lot of the air. Sweet. So like I was saying, it's kind of node based, so you need a good amount of these, but because I was anticipating using sort of like what Gabriel was talking about, the LoRa, they generally say you have about 7 miles between each node to still be able to communicate with each other. So that's kind of what this diagram is showing, is like you have one node and then another node but those two can still talk to each other. So you can cover a pretty big distance without needing a massive amount of these. However, I am trying to make these super cheap so you can have a lot of them as well. So it's not kind of a cost prohibitive thing. Sweet. So, and again, basically in this diagram, it's like when one detects a fire, it then sends that information back to the base station, which is on the right of this picture. And then that base station is what sends it up to the cloud or some sort of dashboard, maybe that is integrated into other systems that are currently available, that could alert with the GPS location of that device where it detected a fire, and that way you can send a response team out there before the fire gets too big and destroys a bunch of land and houses. Sorry, I keep looking up on the left. Either way, so this device basically, here's the device. I wanted it all to fit kind of nicely within a tube. So I don't know if the camera's on, but it what's it? Okay, yeah. So it basically all slides within this tube. One of the big challenges of the project was fitting all the sensors into kind of a sleek enough package and keeping it contained enough to where it could be put in the tube and everything fits. So you could see on this diagram, I've got a circulation fan up top. Basically what that's doing is once these fall out of a plane, they have a parachute that kind of brings them to the ground. And then I've got, I modeled it based off of a lawn dart, which essentially like always tries to upright itself. So no matter how it lands, it should keep itself upright, or if it's windy and it's kind of tipping it over, eventually like it's weighted to where it'll stay upright. Granted, this particular model didn't quite work that well for that, but that's okay. It also has some holes drilled into the side of it, and those holes are at an upward angle, so water can kind of go around it but not actually get into it. So if it's a really heavy rainstorm, it can still kind of breathe, but it won't fill up with water or anything. And it is off the ground, so a little bit of groundwater won't fill it up either. However, because it is all self-contained, I do need a way to kind of suck air into it so it can get a good reading. So that's what the fan up top, as you can see right there, the fan up top, basically anytime the system wakes up, it turns on that fan for about 10 seconds. That fills the chamber with the ambient air around it, and it turns the fan off, kind of lets it stabilize, and then all the sensors start taking their readings and sending that to the next device in line. And that way it can, like I said, it can kind of breathe, but still sort of be weatherproof, because that was kind of another big key that I was thinking about. So yeah, I've got 4 sensors. I've got the GPS, so it always can tell its location. And that Brian and I were joking, like if a bear came and picked it up, you'd still want to know where the bear took it to. So that's why it's got its GPS. It's got the BME temperature and humidity sensor. It's got the laser dust sensor I had mentioned, and it also has a infrared LED that I'm calling kind of like the dead man switch, because this thing is asleep most of the time to conserve power. I wanted some way, in case the fire quickly approached it while it was asleep and not taking data, I wanted some way to have it see the fire around it. So this LED sees the fire, that will wake it up, and then it'll quickly send out a signal like, I'm about to burn, basically. So it has one sensor as kind of a fallback in case it is in sleep mode if the fire approaches quickly. So that sensor's up top. And then it's got the particle, obviously, and the battery. And then the whole thing, I don't know if you can see in the video, or the photo, but the whole thing is wrapped in a flexible solar panel. So no matter which way the sun is around it, it basically can still charge itself and keep enough power to live basically indefinitely as well. Though I'm well aware there is kind of a lifespan to these electronics, but yeah. You want to go to the next slide, Brian? So you could play that. So I got a little carried away and made a little like build montage video. It's super quick, but it's basically like I wanted a circuit board, so I soldered all the components to one central circuit board. This is my first time video editing too. I'm confident in that yet. You can see just more clearly the final kind of design that slips into the tube. I use 3D printing, laser cutting to build this thing. And then it's got a parachute on top.
That was awesome.
Thanks. Oh, yeah, sorry. Something I spent kind of a good amount of time thinking about is I don't want to necessarily add to the pollution in the environment. So like the parachute specifically really is only needed when you first drop these out of the plane. And then it just needs to get it to the ground safely, and then it kind of isn't needed. So what I was imagining is the connection point between the parachute and the device could be made out of something like the degradable stitches or something, or some sort of something that when it first rains or after a set period of time will kind of degrade away. And that way also, if the parachute's sort of like covering it or is nearby and kind of pulling it around, like the connection between those two will eventually break. And that will sort of free the parachute, so this thing will be standalone. The other thing is I didn't really want to just waste leave a parachute floating around. So I was imagining kind of a my roommate's got a dog, but he like those biodegradable plastic bags. So those eventually degrade, and because it only needs to survive one parachute trip, it could be even like lighter weight than that. And when it rains, it degrades away. And then the string could also be made out of something that biodegrades away, so that you're not necessarily adding more pollution into the environment. Sweet. So this is the test video, just showing it works. Oh, this is my favorite part of the project. I wanted to test the parachute part, so I hooked it up to my drone and dropped it. I had a little too much fun with this. Kind of wanted to see if it landed upright. It didn't, but that's okay. Not on this model. And then this is where I'm testing. So right here, there's no fire. You can see on the dashboard. Then I set up the fire. The device is placed nearby. This is kind of it gathering its data. It's set up at a certain frequency to collect data. And then once it does, it shows fire on the right. It shows that there's a fire, and then it also shows the location of where that fire is located, as well as you can see the temperature increase pretty dramatically. So with that one, it was what actually detected the fire in that situation was the particle sensor again. And like I said, that doesn't necessarily need to be placed right next to the fire. If the fire is pretty far away, the particle sensor, as long as the ash kind of eventually the wind moves it over the sensor, it'll pick that up pretty easily. And the other way I'm thinking about it is, even if you don't get it right away, like the source of the fire, it's still better than not having these at all, because basically every second the fire is burning, it's just getting bigger and bigger and bigger. So the quicker you can detect it, the faster you can put it out. Yeah. And then this is, this is the same video, Brian. Oh, my bad. So this is just a test of the kind of like, I'm about to die alert. So you can see there's no fire, everything's green, there's a tree, everything looks good. And then the little IR is built into the device. Boom, it sees a fire, and all of a sudden now the fire indicator light turns and there's a fire emblem. Yeah. So this is just the dashboard. Like I said, I think it would be more useful if it's integrated into some bigger system that is also tracking fires with maybe satellites or other forms of fire detection. But for this project, it was really just like, is there a fire nearby, basically. Yeah, so some of the challenges, like I was saying, is just trying to fit all the components onto like within this 2-inch tube, basically. My next slide is future goals, but one of the goals would be to kind of take all these components and basically create your own PCB with them, as a way to kind of shrink down the whole package so that it could fit in a lot lower profile device. I did have some troubles with the GPS module. It took a sec to kind of figure out how to get that, but I just kept working through that, and turned out my GPS device was bad. So that took a while to figure out though. And then throughout this project, I was really thinking about like, what, if this was actually implemented, what differences would I be changing? And so I definitely spent a lot of time kind of thinking of the real world side of this, not just this prototype version. But the next slide will kind of go over some of the things that I've been thinking about. But that was kind of a challenge because I really didn't want to just build a prototype that doesn't have a plan for how it could actually be implemented. Yeah. So the future upgrades that I'd like to make, obviously, if it's a smaller package, then you can have more of them. Like maybe your helicopter that you're sending out to deploy all of these, you can carry more of them on your helicopter. I'd love to make them a lot cheaper per device, maybe like very, very cheap, would like less than $10 a device, or even less than that maybe. And the ways to do that would be kind of custom PCB, so integrating all of the components, including like the particle, onto one PCB board. And then also just testing more to find the components that still work and get the data that I'm looking for, but maybe are a lot cheaper than the ones that are on this prototype. I want it to really be energy efficient. So all the devices on here do have sleep states. So like the GPS, you can shut that off. You don't need to necessarily send data every single time. Maybe you send it every 4 times or every week or something. But really just being super conscious of the power consumption, because that it would also be useless if the thing just dies out there and then it isn't detecting the fire. So yeah, and like I was saying, the compostable parachute I think would be a good like upgrade. I've thought a lot about the data that you're getting back. So you're getting temperature, humidity, air quality, all these different data points. And I think currently the device is set up to detect the fire on board and then send whether the fire is there or not. But I think it would be more useful if you do integrate that into some sort of maybe like cloud machine learning program that is also looking at weather patterns in the area and is looking at historical data, and really just this will be a device in that data kind of pool and can really get a lot more like accurate determination of whether there is a fire or not. So I think it could be added to some sort of bigger system. And like I was saying, I think it also should be added to other fire detection systems. The other one is going back to not wanting to kind of just pollute a bunch of like electronic devices. And so I was imagining these devices could have some sort of like tag on them or some sort of basically visual. So if a hiker happens to go by, maybe it's got an expiration date on it. So maybe that's 2, 5, 10 years after it was deployed. And if it's past that date, then the hiker, maybe it says like, hey, if you return this and there's already free shipping set up on it. And so the hiker can then return it back and it could get fixed up, or basically it just won't like be polluting too much. And eventually somebody will probably come across them. Yeah. So yeah, any questions? Thank you guys for listening. There's some information. My favorite part was for sure the drone, like dropping from the drone. I had quite a bit of fun with that. Granted, it's more realistically, it'd probably be like a helicopter or plane that's actually deploying them, but I had to test the parachute.